Process strategy is an important component of managing operations in any type of company, whether it is sort of goods or services. And this short video will introduce the concept of process and process strategy and how we make some choices. It is the first of a series of videos on processes and decision making, i.e. choosing and designing processes that I use in an introduction to operations management. So, what is a process strategy? Well, the objective of a process strategy is to build a production process or a delivery process in the case of services that meets customer requirements and product specifications within cost and other managerial constraints. So, some of it might be ergonomics and keeping employees happy, but it is delivering customer requirements in a way that is effective. And so there are a variety of ways we can do it, and it depends on what we are delivering, frankly, right? So is there high variety, or is there a lot of individualization or customization in each item, or is there sort of lower variety, the degree to which where we can just do lots of units of the same type of product over and over and over again. And then we look at volume, how many units we're producing. So here we've got product focus, which is low variety and high volume. So if you think about a baked good where we're making the same bread, or high volume breweries where we're making the same beer over and over again, in those contexts we have a product focused process where we do the same thing over and over and over again. Whereas if we have high variety and low volume, those are often called job shops, where we do individual things for different customers, small volumes. And if you think about it, it's sort of a high degree of customization. If you think about a hospital, for example, we lay out processes in a hospital to say each patient that comes in is going to have different needs. We don't have them go through the same process every patient that comes in. We come in, we do triage, and then we decide where they have to go. And we have processes and layouts, frankly, which we'll talk about later, that are structured around delivering specific requirements for specific needs, or specific processes for specific needs. So we don't have a patient come into a hospital and go through X-ray, MRI, obstetrics. We say, what are your needs? And we send you to the specific process that you need. And in fact, we can, if you come in to emerge, because you're an acute patient, they may send you over to X-ray, and then they may send you over to a stitching room, but they have those processes set up on an individual basis, as opposed to say a service place where you go get your driver's license, where everyone is essentially doing the same thing and the processes you go through are consistent. So that's the difference between sort of process focus and product focus. And sort of mass customization is a combination of those, where you have some degree of customization in a high volume production environment. So really the fundamental here is whether we have a process focus where we customize, or a product focus where we do lots of the same thing over and over again. So how you produce a product or provide a service that meets or exceeds customer requirements, which includes the degree to which it's consistent or customized. It meets your cost and managerial goals. Those things have a long-term effect on efficiency and production flexibility, costs, and delivery. So what you need to do is think about all of these elements and build processes that deliver on them. So there are four different ones, and we talked a little bit about process focus and product focus, and a little bit about mass customization. Repetitive focus is again somewhere in between the two of these, where you have some degree of customization, but you are repeating similar processes over and over again, so that you can, clearly with a product focus, your focus is efficiency, and with a process focus, your focus is on giving each individual customer the specific parameters or service that they're looking for, and the repetitive focus is somewhere in between. So within these basic strategies, there are many ways that it can be implemented. So, you know, we talk about these, and you can be asked on an exam, give some example, process focus versus product focus, and it's understanding the differences in those concepts that becomes key. So in a process focus, facilities are organized around specific activities or processes, right? So in that case, we're not doing the same thing every time. We have, and I use the examples of a hospital, but a machine shop or a welding shop is very much the same, where you have facilities that are organized around specific activities or processes, and things move to those things as is required. General purpose equipment and skilled personnel, so people can do a variety of things depending on specifically what they need. High degree of product flexibility, so the service or the product is very much customized to the individual customer. Typically high costs and low equipment utilization, because not every customer is going to use every piece of equipment. Not everyone that comes into a hospital is going to require an x-ray. And so you have low equipment utilization because you have to have it you have to have it in there in case someone needs it, but it doesn't get used all the time. So you have sort of this excess capacity and low utilization. And product flows may vary considerably, making planning and scheduling a challenge, right? So you don't always know who's going to need an x-ray, so booking regular x-rays, you know, we leave spaces in our day for those emergency cases. So it becomes much more difficult to plan because we're not doing the same combination of processes on every unit that we output. On a repetitive focus, facilities are often organized as assembly lines, and these are characterized by modules with parts and assemblies made previously. So modules may be combined for many output options, but we have sort of the stuff coming in, and we have some customization, but because the modules are relatively exchangeable, we still have the flow like an assembly line. We just might put different things in. So we're repeating similar activities, but we might not be doing the exact same one every time. This is less flexible than process focused, but it is more efficient because you have that flow of products through. So it is more efficient than process focus, and we'll talk about product focus in a second, and it is more flexible than the product focus type process. Product focus, facilities are organized to output the same product, so high volume but low variety. I mean, if you think of a car assembly plant, the differences in most of cases may be no more than color, and any customization happens at the end of that process. You have long continuous production runs that enable efficiency because you're doing the same thing over and over again. And these are typically high fixed costs because you've got a lot of equipment but low variable cost, and generally less skilled labor because you're doing individual people on that production line are doing the same thing over and over again. Not necessarily completely unskilled, but you have less flexibility in those workers or less variety for those workers, and as such, you require less ability to adapt to a specific change in the process. That's what we're talking about there with less skilled. It doesn't mean it's unskilled. It's just usually easier to get people to do that work than in a process focus where they might be doing something completely different in sequential outputs, and they have to be able to adapt to that. Mass customization is rapid, low-cost production of goods and service to satisfy increasingly unique customer desires. It combines the flexibility of process focus with the efficiency of product focus. It is tough to do, but it is increasingly happening with things like computer manufacturing and other things. And so let's talk for a couple of minutes comparing and contrasting. So I'm going to focus on process focused and product focus, and mention a couple of times where repetitive focus and mass customization sort of come in. So with process focus, you have small quantity and large variety of products produced, right? Again, a machine shop. You don't know, you might make 1 or 2 units of something for someone, or a hospital emergency room. One person comes in requiring stitches, other person comes in is having a heart attack, someone else comes in and has broken their ankle. Small quantity, large variety of goods or services produced. Whereas product focus, you're producing lots of a very consistent set of products, and you know, large breweries are an example. Car manufacturing is an example. And in repetitive focus, in some cases, customized cars or other things might be in this repetitive focus. Equipment used is general purpose, so you'll have a welder or you'll have an X-ray machine, whereas in a product focus, the equipment is very specific and it will do the same thing over and over again. You don't need the flexibility. So that's the trade-off, and you've got, you know, sort of combinations of the two in the other two. We already talked about this. In a process focus, operators are broadly skilled and understand the machine they're using and the variety of things they can do. Whereas in product focus, they are less broadly trained because they do the same thing all the time. Now, some companies, even in product focuses, are doing cross-training to allow for continuous flow when people go on breaks or if people are away, but generally those operators are doing the same thing on a consistent basis. And again, repetitive focus is somewhere in between, and mass customization is again somewhere in between. In this case, process focus, you have many job instructions because each job changes, so that the whole of the process is different every time. So you really have to document it so you know each individual operator knows what they are trying to achieve. And in the product focus, work orders and job instructions are few because they are standardized, right? We know the first product is going to be exactly the same as the 1000th product. So sending detailed with each iteration, detailed instructions with each iteration just doesn't make a lot of sense. In a process focus, raw material inventories are high relative to the value of the product because you have to have a variety of raw ingredients or raw material or service staff ready, because you don't know exactly what sort of product or service you're going to deliver. So you need to have more variety of inventory relative because your demand is less certain. Whereas in a product focus, you know exactly what you're going to produce, so your raw material inventories are lower because you're producing this specific product, you know what volume of it you're going to produce, so you know exactly how much of a narrow range of products you're going to need. Work in process is high compared to output because we're always working on that. Work in process inventory is low compared to output because we go from start to finish relatively quickly and there is no variety. The last one of this series, process focus. Units move slowly through the facility and they don't move in a linear fashion. It depends on what specific pieces of equipment or what specific staff need to touch that. Whereas in a product focus, they move quickly through and each individual person, it moves in the same sequence every time and each individual person does the same thing over and over again. Finished goods are usually made to order and not stored. So you have higher work in process inventory but lower finished product inventory because you're making it specifically for a customer. When it is finished, that customer can pick it up. And in this case, finished goods are usually made to forecast and then stored as each customer is going to get the same thing. So we have product ready where we expect to sell it, when we expect to sell it, and as such we can deliver when customers come in. In this, in the process focus, customers order the product and are notified when it's finished. Here, customers come in and get the product because there's not much variety in the products that we're offering. Oh, I was wrong. I had one more of these. Process focus, scheduling is complex. We talked about that. In product focus, scheduling is pretty simple. We run large lots. We know roughly, we forecast well to demand. We know we have a narrow range of products and we produce a lot of it, so scheduling is easy. And again, the other two are somewhere in between. So let's talk a little bit, this is something that I will spend a bit more time with in a different video, but we can talk about different kinds of processes or technologies, and we choose them based on the volume. So we talked in the last slide about fixed cost versus variable cost. Well, in this circumstance, usually, well, the first thing I'll say is if fixed costs and variable costs are low, then you have a technology that dominates all others. So if the fixed costs are lower than process E fixed costs are lower than process B fixed costs, but because the variable costs or the slope of that line are lower for B, there's a point at which B becomes cheaper. If fixed costs and variable costs are both lower, there is never a point that one technology dominates the other, and that's there's never a point that the higher fixed cost and higher variable cost process will be cheaper, and we can illustrate that here. So we have process A as the lowest fixed cost. So fixed cost is the startup cost. So when we've produced nothing, the lowest fixed cost is the cheapest. Then when we start to produce, the variable cost is higher for process A. And so once it crosses process B, which starts higher but rises at a slower rate, at this point, and I'll show you an example, at this point, you prefer process B. And then process C has a lower variable cost and a higher fixed cost. At some point, it crosses C. And then so for quantities less than V1 in here, process A is preferred. For quantities from V1 to V2, process B is preferred. And for quantities greater than V2, process C. So you have these crossover charts, and we'll work on I'll show you in a separate video how to calculate these. They give you a sense of making process or technology choices, and I will have a separate video that goes into how how to assess that, but they are important choices we make based on forecasted volumes. So, in the when we are making decisions, when we take a look at processes, when we are deciding on processes, we have to think about some key questions. Is the process designed to achieve a competitive advantage? Does the process eliminate steps that do not add value? Clearly, those are things that we should think about. We often have processes that have steps in them because we've traditionally done them, and when we step back and do the analysis, we should say to ourselves, does this really add value? Is it a step that is worthwhile for the customer, or should we eliminate it? Does the process maximize customer value? So are we creating value for the customer whether it's a service process or whether it's a product we're producing? Does it maximize customer value, or are there steps in that process that are creating cost or creating delays that aren't actually creating value for the customer? And the last, will the process win orders? Fundamentally, the question becomes, is this giving us an advantage in the marketplace? And if not, we need to rethink that process. So we can do a variety of things. We can do flow charts, which shows the movement of material through and you've all seen a flow chart, I would accept. A flow chart shows the movement of materials, and sequential, if you remember from project management, it shows precedence diagrams too, and it shows the movement of materials, and then we can say, is this step necessary, or are these steps in the right sequence? Time function mapping shows flows and also the time frame. So again, it shows the steps in the process, how long those steps take, and also, frankly, delays in the process, which allow you to step back and say, if we want to take some time out of this, where could we do that? And we'll talk about that more in another video, but this is just to give you some context here. So here's a baseline time function map, just as we wrap up here. Customer orders a product, we process the order, so that comes through here. Production control, the order comes in and it waits till it's scheduled. This is for a printing shop. It is then planted, it goes into printed, and it goes into work in progress inventory. It waits here, it gets moved, it waits again, it gets processed further in plant B, it waits again, it gets moved to the customer. So here it says how long each of these steps take. So we have, in fact, 13 days from when the product is ordered to when the product is printed. So is there a way we can improve the scheduling so that we can get that done more quickly? Again, we have 10 days between actually 14 days. It waits to get moved to the other plant, and then it waits to get extruded. So we essentially have 15 days from when it's printed to when it goes through the second process. And so this time function map shows you not only the flows here, which are interesting, but how long those take, so you can do a real sort of analysis on the efficiency and where you might save some time. And so if I can say, well, I'd like to limit the storage, I'd like to limit the delays between when I get an order and when I print it. I'd like to limit the days between when it's printed and when it's extruded. So in fact, I'm going to do both processes at the same plant, and I'm going to do them sequentially. And then really, I only have to wait in the warehouse once, and we've significantly changed that process. We've structured our operations to say we can get from order to delivery in 6 days. Now, we have to decide, does that create enough value for the customer that it is worth making these changes and aggregating at one plant? But we also have to consider we don't have the work in progress inventory and the costs of that work in process inventory. So the reason we do these time function maps is to highlight where we have opportunities for improvement and to set sort of targets to which we can benchmark our actual performance. So to wrap up, there are a variety of things we can do. We can do flowcharts. We talked about time function mapping. We can do value stream mapping, which shows flows and time and value added beyond the immediate organization. So if things go out and then come back, or if there are other processes that we added. We have process charts where we highlight, and I'm not going to show one today. You can see them in almost any operations textbook. And process charts where we have symbols that show what key activities: storage, actual processing, transportation, wait time, and those sorts of things. So again, that allows us to see visually what activity is happening at that stage of the process. And there's also service blueprinting, which is similar, but it really focuses on customer-provider interaction and is less worried about the sort of physical output, but talks about service. And I will, in a separate video, talk about service processes as being a little different. These concepts are sort of high level and can cover both, but probably a little more focused on products, and we'll talk separately about service blueprinting. So processes are critical. I think there are several things in here that you might see in a multiple choice type question or a short answer question on an assignment or an exam. And sort of the two big things that I would expect you to remember, although any of it is important, would be the difference between a process focus and a product focus. So that's it for this video. Thanks, and see you soon.